In this part of the lesson, we're going to be looking at defined terms and intersections. So just some more vocab, and we're going to take a look at some diagrams, see how things are labeled, see what they mean, see what they look like. So our first actually defined term is called collinear points. What I like about some of the terminology in geometry is that if you just dissect the word, it tells you what it means, collinear, right? Co is like together, and then linear means line. So collinear points are points that are together in a line. But our formal definition is any 3 points that lie on the same line. So you need to have 3 points, and they need to lie on the same line. Now you might be like, but wait, 2 points make a line, right? Well, to have a line, you have to have 2 points. There has to be a third one there to have enough to be collinear. So 2 points automatically going to have a line. If you have a third one on that line, those 3 points would be collinear. So if you look at our diagram down below here, that's the diagram we're going to be looking at while we define these terms. So for example, if you look at this picture, to find collinear points, you're literally looking for a line. So you're going to look for, your line with your double-sided arrow, and you're going to look for 3 points that are on it. I only see this happening in one place here. If you take a look right here, we have this line with a little lowercase m, so that's line M, and that line has points S, P, and T on it. So those 3 points would be collinear. Now, point P, if you look here, is also lying on this up and down line N. Okay, but that's okay. A point can be on more than one. But line N only has 2 points labeled on it, Q and P. Line M has 3 points labeled on it, S, P, and T. So those would be our collinear points. So we're going to say points S. Oh, I need to fix this. Points S, P, and T are collinear, while points blank are non-collinear. So now you can kind of just pick whatever. Any 3 points that aren't lying on the same line could be a good example. Like if you look here, V, P, and T, those aren't all on the same line. P and T are, but V is somewhere else. So that could work. S, V, and P could work. Q, T, and P could work. There's lots of different options. I'm going to go with V, P, and T are not collinear. And if you see an example and you're not sure, just let me know. All right, coplanar points. Again, coplanar, together in a plane. 3 points can make a plane, so to be coplanar, you have to have 4. So it's any 4 points that lie on the same plane. So in this picture here, sometimes it takes a little while to get used to looking at our 3-dimensional pictures on a piece of paper. It's sometimes strange drawings. This is a picture of a plane. So we have our flat surface. Right, so this part here, this represents our flat surface. That's our plane. Then you have 2 lines. You have line ST, right? That's laying on the plane. So the plane continues on forever and ever, and line ST continues forever and ever on the plane. So it's like laying on top of it. Then you have this line here, line QP, and it's actually going through it. If you take a look, see this dotted line part? That is showing you that this line approaches the plane, hits it at point P, and then comes out the other end. That's what's happening here. If you're struggling with interpreting any of these 3-dimensional figures, let me know. Again, I know it's weird to look at something that is like multi-dimensional on a piece of paper. So let me know if you need help. So for our coplanar points, we're just looking for 4 points that lie on a plane. Well, we only have one plane actually drawn for us. That's plane R. And you look at the little R in the corner. So if I pick 4 points that are on it, that would be V, T, P, and S. Some people get confused and they might want to use M. If you notice that M is lowercase, that is not a point. That's just a label for our line. That's like our little lowercase cursive M. I know it doesn't look cursive-y, it's just because of where I got this picture from. But that would not be a point. So I'm going to go with points V, T, P, and S are coplanar, while points blank are non-coplanar. Note, for things to be non-coplanar, that means a flat surface could not possibly connect them. Now, you have to keep in mind that plane R is the only plane that's actually drawn for you here. That doesn't necessarily mean it's the only plane that could exist. A plane is just through any 3 points that you could draw a flat surface through. This scenario, you could actually also have a vertical plane going through Q, P, and T, like up and down. So just keep in mind, sometimes there's more to a picture than what it appears. So to pick things that truly are not coplanar, you have to pick things that there's absolutely no way you could connect them with a flat surface. So what I'm going to do for that is I'm going to pick 3 points that are on the same surface, V, P, and T, right? Those are on the same plane. But if you look at point Q, that's actually hovering up above your plane. There's no way that you could connect those 4 points with a flat surface. So those would be non-coplanar. So we're going to say Q, V, P, and T are non-coplanar. All right, and then line segments. Line segment that consists of 2 endpoints and all the points between them. Okay, so a line segment, imagine you take a full line and you chop the ends off it. That's a line segment. So it looks something like this. You'll have a point, and then another point, and then a little line portion connecting them. That's what a line segment looks like. And if you look at this picture, there's actually a lot of different line segments here. If you look, ignore the little arrows, right? If you chop the arrows off, each line you can kind of split up into different segments. For example, right here, from S to P, that would be considered a line segment. You have endpoint S, and it goes till you get into endpoint P. So SP could be a line segment. So you use 2 letters to name it, S and P. And then with your labeling here, with a line, you put your double-sided arrow. For a line segment, you just put literally a little line segment above it. You don't have to put the dots or anything, just the little bar. So another example, I'll give you a couple, would be like QP, right? From Q to P would be another segment. So let's write that one down. QP would also be a line segment. Your line segment could actually include multiple line segments. For example, maybe we look at segment ST. Sure, yeah, P is in it, but that doesn't matter. You can still go start at S and end at T. That's also a little line segment. So any of those little chunks there between 2 points. So S, T, and there might be some more options. That's just what I'm putting for now. Okay. Then we have array. Array consists of an endpoint and extends from that endpoint in the opposite direction. So an endpoint looks something like this. You're going to have a point and then a little line coming out of it that only goes in one direction. There's actually also a lot of rays in this picture. Now, what you have to be very careful with here, when you name a ray, and I would write this down, you need to start with the endpoint. Rays are really the only thing where when you name them, the order matters, because a ray has a distinct endpoint and then goes on and on forever in just one direction. So if you take a look at our diagram, one example of a ray would be ray P, Q. It starts at P, heads up towards Q. So that's a ray. So I'm going to call this ray P, Q, and then above it you put your single-sided arrow. Your arrow for your symbol here always goes towards the right. Okay, it doesn't matter. That's just how the symbol works. Hold on.
Edlin Janowski, please come to the main office. Edlin Janowski.
Okay. So that's just one example. Now, if I called this plane QP, then I'm implying that the ray is going in the exact opposite direction. So the order you write it in tells you what direction your ray is going. So if I say ray PQ, it's going from P up towards Q. If I say ray QP, it's starting at Q and going down towards P. So the way you label that is important in this situation. Another example here could be ray PT. All right, that would start at P and head towards T. So ray PT. If I said ray TP, that would be starting at P and going towards, starting at T and heading towards P. So be careful with that. That's something that's easily confused. And then our last one for this diagram is opposite rays. So opposite rays, it's exactly what it sounds like, rays that go in opposite directions. So for our actual definition, though, we're going to say two rays that have a common endpoint. Okay, so that means you're going to have an endpoint, and you're going to have one ray that goes in one direction and one ray that goes in the exact opposite direction. So they start at the same place but go in opposite directions. So in this picture, you have opposite rays from P to T, right? That starts at P, heads towards T, kind of up and to the right. Then you also have the ray going in the opposite direction, which is starting at P and heading towards S down and to the left. So that's an example of an opposite ray here. And when you name these, it's also very important you start with your endpoint. So ray PT and ray S, I'm sorry, I just did that the way I told you not to do it. Ray PT and ray PS would be opposite rays. They both start at P and head in opposite directions. And then for the last part of this video, we're going to talk about intersections. Intersections is basically where two things cross, right? Think of an intersection on the road. It's where two streets cross. So you can have a few different scenarios with intersections. Two lines intersect at one point. So here you have two lines, and where they cross, they form a little point. So anytime you see two lines crossing, that's going to form a point. Two planes intersect at one line. So that's this picture here. This is a vertical plane and then a horizontal plane. Think of like if you had two pieces of paper, right? They intersect along this entire kind of like edge. So that's your line that they intersect along. And then lastly, a line and a plane intersect at one point. We actually saw this in the picture above. You have your flat surface and your line will approach the plane, intersect it at a point, and then come out the opposite end. So anytime you see dotted lines like that, that means it's behind it. So this would intersect at a point like that. Okay. And in the next video, we'll get into some examples.